In the classic clip of on America's oh sorry, I just took an edible. Funniest home videos, a sleepy cat gently ro- rolls gently off the top of a worn TV set, ignoring air resistance. Calculate its position, its velocity after a certain amount of seconds. All right, before we start, folks, let's draw a cat. So this is going to be a cat. There you go. I don't know what the fuck. There you go. There's this cat is falling, and nature builds specifically the cat so that they can land on the feet. It's very incredible. You guys should look into that. But anyways, so and when you fall, folks, you know that you're gonna hit the ground. You know, the taller building but I don't. If you fall from a higher building, you're gonna land the ground much harder, and the reason for that is because you're gonna hit this. You're gonna land at a speed, at a velocity much higher, and that velocity builds up over time. And the change of velocity over time is what we call gravity, folks. Flat earthers don't believe in gravity because they're so freaking retarded. But gravity is 9.8 meters per second square. That is the change of velocity per time interval. That's all you have to do. And the velocity is a constant velocity where if you land, this is the kinematic equation. So A is G. Change of v equals at, or in this case gt, however you guys want to model this. I'm going to put it as at for now. And the change of position is v naught t, some initial velocity, it could be 0, plus at squared over 2. And the question is asking for the position and the velocity. So in other words, let's set up those two equations, two unknowns, and in other words, folks, the position, I'm going to call down positive. Generally, I would normally call down negative, but I'm going to call it positive. So in this case, the height, the downward, that is, it travels, is going to be some initial velocity, well, not if it falls, so which is 0 meters per second, some initial position, which you can just call that 0, plus gt squared over 2. There we go, folks. That's beautiful. And the final velocity is really just going to be nothing more than at, or in this case gt, and g is 9.8 meters per second square. So this equation is going to be, and the reason why I'm taking a little longer on this video is because, you know, we're going to be using these equations again and again and again. 9.8 meters per second square, t squared over 2, and the velocity is nothing more than 9.8 meters per second square times the time. So this is the equation for the time. This is the equation for the velocity. So in other words, it's just, so I'm going to put this on my calculator, and it's actually, let me do this. 0.1 square. Okay, so the position for part A is at 0.1 second. If t equals 0.1 second, the position is going to be 0.049 meters. If this was 2 seconds, 0.2, the t equals 0.2 seconds, the position is going to be 0.196 meters. And at 3 seconds, 0.3 seconds interval, if t equals 0.3 seconds, the position here is 0.441 meters. For part A, the velocity is just 9.8 times 0.1. So let me just set that up. So if t equals 0.1 seconds, the velocity, or I guess we can just call it speed at this point since we're not going to worry about the direction, is going to be 0.98 meters per second. In 0.2 seconds, if t equals 0.2 seconds, the velocity is going to be 1.96 meters. And I feel like I did this wrong. What the well, maybe it's correct. And if t equals 0.3 seconds, the velocity is 2.96 meters. This matches to that, so let me just double check the other one. 4.9 times, was that 0.2 square? Yeah, I guess it does match 0. Yeah. So once you put these in the calculator, right, these are your values, folks, and that's all you need.